Okay, we are live. Keith McCormick from Cloud Factory and James Taylor. We were just chatting, and we've both been very much looking forward to this all month. So, time is precious in a 1 hour live event like this. So we're gonna jump right into it. But one quick preliminary: we love taking questions, but in a live event, the comments are gonna be flying by. So what I want and to encourage everybody to do is tell us that you're out there. In StreamYard, we don't see you. we don't even see a list. This is how you can communicate who you are and where you're attending from. So name and where you're joining us from would be fabulous. And in about a half hour or so, we've got an hour together. In about a half hour or so, we're going to start really attending to comments. So for now, really excited to get those comments telling us who's joined. In about a half hour's time, that's when we're going to switch gears over to questions. So James, something that's always on my mind, in fact, something that I asked our common friend, Dean Abbott, last month, is you read, all these industry articles, and they have this incredibly pessimistic numbers about deployment. In your experience, when you're working, well, not with your clients, certainly, but when you're out there in the world, do you sense that the numbers are accurate, that it's as bad as they say? And if so, why? What's going on?
Oh, I think it's actually worse.
Okay.
Because I think there are a lot of these surveys, particularly when you get into machine learning and AI kinds of analytics, they're including pilot deployments. And they're talking about people who've got a pilot deployed or a proof of concept deployed. And I wouldn't count that as deployed, right? I would say, well, that's nice, but it's not deployed because it's not operationalized. So I think actually, if you were only to count, if you like, what we lovingly call big boring companies, so real companies with real, histories and not digital natives, and you were only to count things that were actually in full production, I think the numbers would be worse. I think it really is as bad as it sounds. Right? I think there's a tremendous amount of money being spent, a lot of work being done, a lot of very interesting models being built, and a surprising dearth of really good results. Go read the case studies. They're full of weasel words. When fully deployed, is expected to, should, will.
Or conference presentations. They're always very excited. Right. They're always very excited about next year. James, I want to greet a couple of folks. We have a lot of interesting folks joining already, and then I want to circle back to ask you about why you think it is that that bad. So Adrian's joining from the UK. Welcome, Adrian. Gopal from Nepal. Dalton, definitely recognize some names of folks that I know. David from Kenya. Renee is joining from Denver. Boy, we've got quite a few time zones represented for sure. London, Atlanta. So thanks everybody for coming. And again, I'd love to see those comments that you've joined us. We'll be really turning our attention to questions about halfway through our time together. So James, if it's even worse than Gartner and McKinsey and some of those folks were saying, then right. what explains that? And it's apparently you agree that this has been going on for years, if not decades, because we've both been at it for a while. So how can it be that the track record is that bad for that long?
So first of all, I think you have to remember where we all started with some of these things. If you look back into the history of decision making using analytics, a lot of it's in like retail credit and in certain kinds of risk-based industries and fraud detection, and a few very well-defined use cases. And I used to work in that industry a lot. I used to work for FICO, and we had lots of those kind of customers. And what I was struck by when I started working with other customers is they had much less of a sense of what they were going to use the analytics for. If I'm a big bank and I've got a credit risk score that predicts your credit risk when I give you an unsecured loan, and the analytics team builds me a better one, that's easy to use, right? Because I already know how to use it. I've already got all my processes and organizational structures and everything else geared up to have a score for that. And that started back in the 50s. Right? But in most industries, they don't have anything like that history. And so it's much less obvious how a quote better model is going to immediately make a business difference, right? And so what we see is two big issues, right? The first is that they build a model, but they can't get it into production, right? It's not operationalizable. I realize that's a terrible word, but the great thing about being, I'm an American citizen, right? And the best thing about becoming an American is that suddenly you can make up words.
Yeah,
it's allowed, right? Other countries don't allow you to do this. It's one of the hidden benefits of becoming a US citizen, right? Power to make up your own words. So, models are not operationalizable. number one. And secondly, if the model is operationalizable, it's the wrong model. It's not a model that's actually going to be useful, right? So, we see both those problems, and we use sort of deployment as a shorthand for it. And I think those of us who've been in the industry a long time, we used to say, well, deploying a model is hard, right? And that included recoding the model so you could run it in production. Well, now that bit's easy, much easier, right? The tools have got far better at deploying the models, and the price performance of hardware and cloud mean that even if your model's building code is crappy, you can still run the whole thing in production anyway, because you can just buy a big box, right? It's easy.
Yep.
The problem is that was never the biggest problem. It was just the proximal one. Yeah.
It's interesting because I've been at this for a while, as you know as well, but I've never thought about it that way, that some of the most famous use cases, churn, fraud, default, that we always talk about these use cases because folks did the hard work of defining those problems some time ago, and in some ways we're borrowing that work. But when we go into the newer use cases, folks just aren't doing the hard work of defining the problem in such a way that you can do all those things. Operationalizable.
Yeah, there we go. I had this great call once from this guy, and he was asking me, did we build churn models to talk about churn? And I said, well, we can certainly help you with a churn model, but humor me. What are you going to, what's your role? What decisions do you make that you're trying to improve with this churn model? And he said, well, I run the save queue for a telco. We have a real churn problem, and I really need to reduce my churn. I need to get more of my customers to renew. And I'm like, okay, so you run the save queue? He said, yes. I said, just the save queue? Yes. Okay, then I can give you a free churn model. And he says, you can? I said, yes, churn equals 1. You're running the save queue. You're only speaking to people who've already said, hey, I'd like to cancel my service. Yeah. That means they have a 100% risk of calling to cancel their service because they have, in fact, already called to cancel their service. So he didn't need a churn model. He needed models that would help him figure out how to retain people, right? Yeah. What offer will they accept? Are they worth retaining? There were lots of models that would be useful, but a churn model, not so much.
That's really something, because I don't know if everybody who's joined us today is appreciating the humor in that, because there are some things we encounter. It's just immediately funny to us that somebody would think of it that way. But it seems to me that that's both the positive and the negative of analytics starting within the line of business. That if analytics starts within the line of business, you have sponsorship. This is a good thing. This is something to be excited about. But if it starts within the line of business, sometimes you don't have the big picture. And, your story about everyone in his queue, is a positive, again, to us humorous, to others, hopefully somewhat, insightful as well.
Hopefully, yes.
And it's plausible that somebody would make that mistake, even though it's the kind of mistake that would cause us to chuckle a little bit. So I want to pivot a little bit to going big picture ourselves, just the two of us here. Last month, when I was talking to Dean, we were talking about machine learning, and I think a little bit about me. I'm the guy who builds the models and so on. But you really do emphasize that bigger picture of where those models are going to live. So help people understand a little bit the difference between a deployed model and what you do with decision management.
Sure. So many years ago, a guy who ran the analytics team for a big financial services organization said, the thing about predictive analytics that people forget, and I'll include machine learning in this, the thing about predictive analytics, he says, is they don't do anything. They just make predictions. And so the question is, well, a prediction is interesting, but it's only useful if you do something because of the prediction, right? And so what we specialize in helping people do is really say, well, what is it that you're trying to do differently because of the prediction? What would it have to predict in order for you to do it differently? And what are the other constraints on what you can do? Because in reality, if you're as I lovingly call our customers, a big boring company, right? A big established company. Well, you've got contracts, you've got a position in the market, you've got a brand image with your customers, you've got history with your customers, you've got all this, right? You can't just throw that out, right? You're not some digital startup that can just say, well, the data says I shouldn't do any of that stuff. I'm going to do something different. Well, no, right? You don't get to do that, right? You don't get to suddenly not follow the regulations. You don't get to throw your contracts out the window, right? So any decision you make is constrained by those things. The guide rails and the constraints have to exist. And what you're hoping is that the machine learning will enable you to make a better choice amongst the ones that are allowed, right? That's what it boils down to if you're a large company. And so most decisions, most actions that you're going to take can't be driven only by the model. There has to be a set of rules and regulations and compliance and policies and so on that also affect how you make the decision. And the model is helping you pick between the ones that you might do, right? And it's interesting for me. I mean, I talk to, like you, I go to a lot of conferences and speak a lot. And I meet a lot of people who are very excited about machine learning. And they all talk like machine learning and AI is a separate thing. It's all its own thing, right? And then I live in Palo Alto, so I've ridden in a self-driving car with one of the engineers from one of the self-driving car teams, right? And he said, well, obviously, to make a self-driving car go, you have rules and you have analytics, because its ability to say, oh, that's a truck, that's a car, that's a pedestrian, that's a dog. Well, they're using analytics for that. But when there's a stop, oh, I think that's a stop sign. Well, that's all analytics. That's all AI, machine learning. But the rule that says if it's a stop sign, then stop. Well, they didn't teach it. They didn't let it learn that. They just told it.
Yeah.
They wrote a rule that said stop at stop signs because that's the rule.
Yeah.
And so and then I was talking to some guys at IBM about this Mayflower autonomous ship. Have you heard about this thing?
No. That one.
There's this project called for the 500th whatever anniversary it is of the Mayflower to build an autonomous ship and sail it across the Atlantic, right? So it's being tested up in New England somewhere, and obviously it does a tremendous amount of AI about the waves and what's going on and stuff. But the thing is, it's a ship, and there's this whole body of things that the Coast Guard write called the COREX or something, the collision rules, regulations, right? About how you have to behave relative to other ships so that two ships don't both turn the same way, turn into each other, right? And so, well, that's a bunch of rules. And so this ship uses all this AI, and it uses a business rules management system to manage the COREX. And the one of the brains behind it said, there's no real world problem you can solve only with AI or machine learning. You always need a set of rules as well. And that's our experience.
Yeah. We have so much to talk about. I have to be careful about getting.
We only have an hour
here. But what's fascinating is if you watch the folks, folks that are incredibly skilled, like a Jan LeCun or a Jeff Hinton and so on, since they're, as academics, they're always kind of 10 years ahead, or I guess Jeff Hinton always likes to say that you can kind of predict 5 years, but beyond that, it's hard. So let's just say that they're always trying to be 5 years ahead.
Sure.
General AI, like the robots of the future and so on, would have to figure out about the stop sign on their own, or they would read electronic.
Well, but the question is, why would you, even if you could allow a self-driving car to figure out that it ought to stop at stop signs, right?
Yeah.
Why do we have stop signs? Well, we have stop signs because we had a ton of accidents at intersections until we put stop signs up. Well, we already learned that. Now, I guess we could start again. Yeah. Just put a bunch of self-driving cars on the road. They'll keep hitting each other. And then eventually they'll figure out that when they see one of those big red signs, they should stop.
Yeah.
Right. But that seems,
well, again, it's humorous or even slightly sad, perhaps. But I think it's because the expert systems of the 80s have gotten a bad rap.
Oh, yeah.
Because they're not general AI, right? So I'm sure you have some client engagements where you get there and the kind of techie machine learning types are going, rules. It should figure everything out. Okay, so I'm not imagining that. That's Silicon Valley is so hot, but I think that, well, wherever we might be in 50 years, I'll be 102. Even be a little older. Wherever we might be then, I don't know. But at the moment, absolutely, we have the marriage of rules and what we would call propensity scores, right?
Yeah.
I want to make one more quick point about propensity scores and have you respond as well. For modelers like me, when we're starting out, late 20s, whenever it might be, if we get a gig, we're usually not at that stage in our career. It's not easy for us to turn down the gig. So if they want to have us do a propensity score and they can't articulate to us what they're going to use it for, I think most young data scientists just kind of do what they're told. At this stage in my career, I can turn that client down. You can't even start. You can't even begin to do what you do unless they can articulate. So in other words, have you had to fire a client because they just don't get it.
I'm not sure I would say we've fired a hunt. We've certainly had some where we can't get past the initial conversation because they just, I remember having one and they called up and they said, I've got this new role and I've been tasked by this large manufacturing company to look for some immediate big wins, swing for the fences kind of analytic projects where we can bring data together from multiple divisions and figure something big and strategic out. What should I do? And I said, take a different role.
Yeah.
Because really, I think you're just going to spend money. Because you're a big manufacturing company, the right thing to do would be to go find decisions that you have to make in order to make the things you make that you don't feel like you make as well as you might do, right? Or that you're making consistently, or that if you could make them better, there's money to be saved. And then go off and see if you can build analytics that will help you do that. And then even if they only make a very small improvement, they save you, $1 a vehicle or whatever it is, you make a lot of vehicles. So, it's like the savings add up quickly, right? Because you do it over and over and over again, right? And so we occasionally have clients like that they think they're going to do one thing with machine learning and with AI, and we're like, yeah, well, we don't think you're going to do that. So, no, can't help you.
Well, that makes sense. Yeah, it's not like you go to the doctor and the doctor tells you to cut down on steak or something, and somebody's like a non-compliant patient. In your case, right. From the first meeting that something's not quite right. So in some cases, it just hasn't been a good fit because
it hasn't been a good fit. Yeah. Exactly. Yeah. I mean, what I would say is, it's not unusual for us to have clients who started off as bad clients and then go off and they build some models and they do some stuff, and then they come back and say, okay, this is not working. Can you help us figure out why? Right. And we go, sure, right, and we can do that, and then we'll sort of backfill it. So we had one, for instance, where they had built a provider risk score and for claims fraud, and it divided claims up into risk quintiles, lowest quintile, second, third, fourth, fifth, right? Classic model, right? And no one was using it, and they couldn't figure out why. And so we went and I like to joke, we cheated. We went and spoke to the people who actually have to decide if they're going to pay a claim or not, the claims adjusters. This was a group of people, of course, that the data science team had not actually spoken to.
Oh gosh,
they had all this data, right? So why would they need to speak to the claims adjusters, right? And we asked them how they did this, and sure enough, the provider being potentially fraudulent was one of their decisions, part of how they decided. But it was a sniff test. Does it smell bad or not? Right? If it doesn't smell too bad, then we keep going. We check other things, right? And we said, okay, so why aren't you using? Because they had done the whole model deployment thing. They figured out how to deploy it. They built a little web page. You could type the provider name in right in your process, and it would tell you, which quintile it was in. So there was no deployment issue. And these guys said, well, because we just don't know which quintiles are meant to, smell bad. Is it the top quintile that smells bad? The top 2 quintiles? Top 2.5 quintiles? Because it's the worst ones? I mean, And so we said, okay, for the purposes of this conversation, from now on, you can assume that if it's in the top risk quintile, it smells bad. And otherwise, probably not, right? So, work with that for now, right? And we went back to the analytics team and told them, and they were like, and I'm like, so how long did you spend getting from, if I told you needed a yes-no model, how much less time would that have taken than getting to the well-defined mathematical quintiles? Yeah, well, that would have been several months. They'd have been done much earlier. If they'd just gone and asked them, they'd have said, I need a sniff test.
That context, I was saying earlier that one of your stories made me chuckle a little bit. This one is making me sad. That's the emotion I'm experiencing right now, because that context is so incredibly important. Even some of my favorite modeling buddies will tease me a little bit about how much, not just visiting with the folks, with the end users, but really spending some time. I like to sit in on claims calls. Yeah, not endlessly, but like an hour, because what I find, and I found this on numerous projects, I could give a half-hour stories right off the top of my head, but where I just sit in and listen to the calls, and after the call, I've got a whole bunch of notes, and I go back to IT and say, wow, they were talking about this thing on the call, this process or this step or this indicator, and that was nowhere in the data dictionary. Oh, that was in this other table. You need to know about that, So. So people probably think, oh, well, what am I doing? It seems like Keith is getting in the weeds there, but I'm just seeing if there's a marriage between process and the data that I've been given as a modeler. And, we probably deal at different levels. I'm probably dealing with the director level types more often. You're probably dealing with the C levels more often because of what we do in the process. But that context is so invaluable that I just can't believe there are still modelers out there that don't ask questions.
Oh, well, they do. I mean, the thing is, you see, I think that's a little harsh on them. There are some, don't get me wrong, right? But most of them, they do try and ask questions. They want to know what the metric is. That they're like following something like Chris. They're trying to get some understanding of the business problem. What's your problem? How would this be valuable? What data do you have? Right? They're asking those kind of questions. But what they don't have is a concrete way to represent what they learn about how the people make decisions today. Now, we're big believers in like design thinking. And if you go to like the design thinking school up at Stanford, just up the road from me, for a long time, they famously had this big sign outside the door saying, "You are here." Right? One of those big "You are here" signs, because they said one of the essence of design thinking is you have to know where your people are before you can help them find a better place. Right? And the problem with most data scientists is they don't have tools in their toolkit for finding out how the people they're trying to help make their decision today. Even if they ask them, they don't really have a tool for capturing it, right? And so we use decision modeling a lot, because then we can go, hey, claims adjusters, managers of claims adjusters, how do you decide? What is it you decide? What are the pieces of your decision making? Which bits are regulated? Which bits are fixed? Which bits are, based on your experience? And then once we know what the pieces of this decision making are, then we can go say, okay, so if there's any bits in here based on your personal experience, we could probably enhance them by using everybody's experience, using analytics, right? And secondly, we play this game. We call it the if only game. We say, this is how you decide today. Fill in the blanks in the following sentence. If only I knew blank, I would decide differently. Yep. If only I knew which providers were fraudulent. If only I knew which claims we were going to get sued over. If only I knew, which delivery was going to the wrong address, right? If only I knew where there was going to be traffic. Well, okay, so now the analytics team has a question. Well, can they answer it? And then they can say, well, if I could answer that question for you, how accurately would I have to answer it in order for you to make a different decision? And I already understand the decision context, so I know where you are. Are you remote? Are you in the office? Are you in front of a computer? I know what you're trying to do at the moment. I know what data you have available, because it's a point in a process, a point in a system. And so all the questions that would normally undermine my ability to build a good model go away.
Yeah. Right? That's so fantastic, because that really defines the machine learning piece. It's not the whole project. The project isn't machine learning. The project is the machine learning part is the if only.
Yeah, exactly.
And is used in conjunction with the business rules. So I want to pivot to kind of a different part of our conversation, but in particular where humans come in. And I love the way that you've described the conversation that you have with some clients where they've got that propensity score, and then that they figure that the human's job is to come in at the tail end and then see if they agree or disagree with this whole, this whole process that you've done. And I know in a lot of your articles, this is a well-defined process. I know you're talking in your articles about decision management notation. So this isn't just a chit chat with your clients. This is a very careful discussion about how the decisions are made. So if that's not the way to do it, if the human coming in at the tail end and saying, "Oh, I'm not sure if I agree," if that's not the way to use the human, what's a better way to use both the human employees and in some cases external folks?
Sure. So when we build these models, one of the things it does is break the problem down into lots of smaller decisions, right? You're saying, in order to make this decision, I first have to make these decisions. In order to make each of those decisions, I have to make these decisions. So you break them. It's like a dependency network, right? Well, some of those decisions are well defined. There's rules for them. There's policies, regulations. Some of them are, I need to know the total value of your claims over the last 12 months, or I need to know if you've ever been more than 30 days late on 6 of your accounts or not, right? Analytical kinds of things, right? Great. But there are other ones that are judgmental, right? And then for those, you just say, well, that's a human judgment, right? So we did one for a well-known medical clinic. We're building out a decision model as to what the appropriate treatment is for someone with a particular heart condition. One of the decisions in the model is, does the patient look like they will survive surgery? And the IT guys are like, well, how are you going to automate that? And I'm like, well, I'm not. I'm going to ask the surgeon. And they're like, well, why wouldn't you just make a recommendation without that piece of data and then have the surgeon go, well, yeah, but I don't think you're going to survive, so I won't do surgery, right? And the surgeon, who was the head of surgery, he was the referring surgeon at a clinic you get referred to if the referring surgeon at your local clinic thinks you're difficult. So this is like one of the world's top surgeons. He goes, well, because sometimes even if I don't think you're going to survive, it's still the right option because you're dying right now.
Yeah.
Right.
Well,
and if I don't do surgery, you're going to die. So even if I don't think you're going to survive the surgery, it's still the right recommendation because his judgment was essential to the decision. But letting him override it means that he doesn't, that there's no guarantee that he's taken account of all the things that the model would take account of. Right. So it was much more effective to have his judgment be an input to it.
Yes.
Than it is to have the engine go, well, I'm a stupid computer. As far as I think you should do surgery, and have him go, nah, don't be silly. He's going to die if I do surgery, right? Well, because he has no way of telling that the engine said, do surgery no matter what, because this guy's dead if you don't do surgery, or if it said, do surgery because that's probably better than not doing surgery.
That's so valuable. So I want to stay on that, but we have a little bit of housekeeping to do here.
Sure.
So what we're going to revisit is this notion that the subject matter expert within the organization isn't an override. That's not the ideal way to do it, but an additional input to the model to be combined with other variables.
Yeah, right, exactly. Yes.
And because I want to come back to that because I know we have another example of that additional input. So a little bit of housekeeping, everybody. Hope you've been enjoying the conversation. I certainly have. So if you take a quick look at comments, it'd be a great idea to go ahead and follow James, certainly. Follow all of us at Cloud Factory because we're going to have an event like this every month. And the folks, my colleagues at Cloud Factory have helpfully put some of those links in there. Make sure to open an extra window. You don't want to click on the link and leave the StreamYard. We're not done yet. So,
but if you do, goodbye.
But make sure you open another window. And then make note as well of the next event that's coming up. I also want to acknowledge that I saw a comment about revisiting manufacturing. I know that we're going to talk about something a little bit different first, but we are going to start paying attention to the questions coming in just a few minutes. So back to this idea of additional input. Mm-hmm. There was a phrase that I don't know if Dean made up, as an American, he has that right to make up words. Right. And I don't know if he made it up on the spot or if he's used it before, but we were talking about the squishy middle where there may be times where the appearance of the patient might override the decision, but other times when it doesn't, right? Like when this patient absolutely needs surgery, regardless of appearance, right? Right. So what Dean was calling that, his made-up phrase, is the squishy middle. Okay. So and I think we're talking about this, some time ago. I think you had a client. Possibly in the disability area, where there was a deciding factor that could take them out of the squishy middle and put them in a clear yes or a clear no.
Yeah. So we had this example. So it was a disability claims, and this was to fast track the claims. And it had two interesting things to it. The first was we built this decision model, and it became clear that part of the decision was whether or not the medical report that came with the claim described you as having the same condition that you were claiming for. Right. And the analytics team was all super excited because they were gearing up for text analytics because they had figured out that this was going to be the case. But then when they listened to the exact description, they're like, wait, so you don't need to know what all the conditions are in the medical report.
Oh, gosh.
You just need to know if the one they're claiming for is in the medical report. And they said, absolutely right. And they're like, oh, well, that'll be easier because we thought we had to go through and sort of come up with the ICD-10 codes or whatever it was that are referenced in the report. And in fact, we don't. You're going to tell us which one you're looking for. And all we have to do is basically come up with an algorithm that says, yeah, it matches more or less, right? And then they said, okay, how accurate would it have to be? And they said better than 50-50. And the analytics team practically fell off their chair. In fact, they made them repeat it so they could record them saying it because they didn't believe them. Because they were like, it's a fast track decision. We're just trying to decide if we should fast track it or not fast track it. We're not going to pay it yet. Right. So we only need a quick sniff test. Right. And what was interesting about it was that they were going to go off. And this was a relatively large project, right, to go off and do this, even that level of text analytics. Obviously, I had reduced the scope of this analytics from a 95% accurate assessment of all the conditions in the report to a 50-50 judgment whether a particular condition is in the report. So I'd already de-scoped the analytic by 80% or something, right? But it was real work, right? And in those circumstances, it seems that you didn't need to be an expert in claims or in their policies or procedures or know anything about the patient or the claim or anything else. All you needed to do would be to be sent the text of the medical report and the condition they were claiming for, and asked, is it plausible that this medical report contains a description of that condition? Yes or no?
Yeah, it's a brilliant example, because I think when you first told me about this case study, you mentioned mobility, and if I hurt my elbow, it's less clear how that's affecting my mobility. But if it's ankle or knee, that makes more sense. Right. So it's a little bit more sophisticated, certainly, than you'd want to do something like with crowdsourcing, right? Because you want some training, but you certainly don't need a medical student. Nope. So it's certainly
nor do you need an employee.
Yes,
because they don't need to know your policies. They don't need to see. This is the thing. Once you break the problem down, you're not trying to pay the claim. You're not trying to make a decision about the claim. You're making a much more focused decision. And the problem is, as long as you think the problem is, I've got to decide about the claim, well, then you could only use an in-house data science team. You've got to use all the data. You've got to have in-house people, because paying the claim is a big business decision. It's important, right? But in this case, it's just a random ass medical report about someone. You don't even need to know who, right? You just need to tell me, this person's claiming for a broken leg. Does the doctor say they have a broken leg? Yes. Great. I'm done.
This is so brilliant, because what happens is the machine learning folks that are right out of their masters, they're obsessed with replacing the process altogether with the model, right? And then alternatively, people think, gosh, we got more claims to handle than we can handle. We're going to have to outsource like the whole thing, right? And neither of those really make any sense, do they? Because what you're doing is you're outsourcing to the machine, if that's a phrase that makes sense, the what if,
right?
Okay. And you're outsourcing to the human. That's this middling level of skill, not medical doctor, as you point out, not even employee. I mean, they don't, we're not talking about, somebody that has to go through 6 months or 12 months of, of training, but more sophisticated than crowdsourcing to clarify an input, because you might have 20 inputs or 30 inputs into this process, and one of them is unclear.
Right.
If that input gets resolved, then all 30 produce an accurate score. I mean, it's really, it makes so much sense when you hear it, but
The other thing it does, Keith, that I think is really important for the data science people listening, is that it creates a data set. Because the problem that data science team is going to have is, what it had was a set of claims, whether they were fast-tracked or not, and then paid or not. It did not have a single record telling them whether someone had looked at that medical report and confirmed that it matched the claim. Not explicitly. That would explain many of the not fast-tracked, and it would explain many of the rejections. But there were other reasons it might not be fast-tracked, and other reasons it might not be rejected, right? So their training data set was crappy.
Yeah.
Right? So you don't try and train it to start with. You take that one task, you have somebody do it, and not only are they doing it so you're getting an immediate value out of your process, you're getting this decision made more automatically, you're also explicitly creating the exact data set you need. Did this text match this condition? Did this text match this condition? Over and over and over again. And that is, in fact, the training data set you need to build a model.
Yes, absolutely.
So you can do both. It's not an either or. Do I train the model or do I automate the process? You can automate the process now and create the data set you need in parallel. And I don't understand why everyone's not doing it, except that I know why they're not doing it, because they don't really understand their decision making.
Well, yeah, they're not having that detailed conversation about how we make decisions now.
Exactly.
And at the risk of being fancy, what counterfactuals are missing, right? What ifs. Yeah. I'm a big Judea Pearl fan, and he loves talking about counterfactuals, but that's all they are. They're the if onlys.
Right. Or places where we rely on someone's judgment, right?
But what is so
Yeah.
brilliant about this, and I'm sure anyone who's on the call, and I know some of the folks that are on the call that have, a half dozen or a dozen projects under their belt, this resonates with them right away. And I think what happens is that there's a lot of folks out there that just haven't seen the light, but it all makes so much sense. So, so what I was going to try to describe is kind of some iterations through the model, using the example that you were doing. What some people might be tempted to do, but I think we would both agree that it's a mistake, is postpone deployment while they're waiting to do this fancy text analytic piece. Because what you were describing so brilliantly was they probably don't have a high quality enough training data set to do that at the moment. So for goodness sakes, go to market with what you have, which is take the structured data, get human support, right, on your unstructured data so that you can go to market right away. A year from now, you're living in a different world because you have an improved data set. Maybe you initially have 15% of cases routed to an external resource, but maybe 12 months from now, you can cut that down from 15% to 8%. Who knows?
Yeah, right.
And maybe in 3 years, you can even start to do some of that with text analytics. But for goodness sakes, don't turn this into a 2-year project, during which you're getting no value.
Right, exactly.
Now, there's a couple of things that I just want you kind of thinking about here. Had a question thinking in particular about combining rules and machine learning with underwriting. Right? And I think that's certainly your bailiwick there, because I know you've got a number of insurance clients, but also manufacturing. And I've worked with some manufacturing clients, if an example doesn't come to mind. But before we do, and then we're going to start taking questions in earnest, I want to kind of somewhat circle back on the themes that we've done so far. And I've been writing a series of articles with my colleagues at Cloud Factory about return on investment, and this whole idea of don't wait for the perfect model. It's not coming, and if it ever comes, it's not coming this year. Go to market this year with what you've got. And I love, again, what you said about not only are you bringing in value, monetary value, you're saving, you have a more efficient solution, but you're also improving your data set while you do so, because that, whether it's a managed workforce option like, Cloud Factory, or possibly something in-house or whatever they might be doing, that whole improved process is also improving the training data set. So you're getting immediate value, and you're accumulating this better data in your data bank account, right?
So you also, as an aside, take the rules-based judgment that they think is true, and you record the outcomes of that. And so you get a data set that will enable you to validate whether your experts are in fact smoking something when they say this is the threshold, or in fact if they're right. So you get to improve their judgment. You get to create the data set that will let you validate their judgment too. Yeah.
I'm smiling, Jason, because my colleagues Jen and Amanda are really on top of things here. They've got the first of the 3 articles in the comments, and the second one is coming out next week. In fact, I may quote you from today. There's a couple of business days between that and when we go to press, and if there's a juicy quote, there's already been a dozen of them, then I might sneak that into the article. So that will be a lot of fun, and please look for that next week. So what I wanted to do to kind of tie those up, and then again get into Q&A in earnest here. By the way, folks, I've been jotting down questions as they come through. So if you see me breaking eye contact, that's not disinterest. That is me using a pen with paper. I'm being very old-fashioned here. So I wanted you to talk a little bit about your idea of a valuable analytic.
Sure.
Because I've been using the ROI phrase, but you have an interesting way of defining that. And in particular, if you could kind of tie it into the case study that we were just doing, in what sense could this combination of a human reading the paragraph combined with everything else, how does that accomplish what you would call a valuable analytic?
Sure. So I have this definition. I'm going to read it. So that's why I'm breaking eye contact, because I'm going to read it so I don't forget any of it. And I write it like it's a dictionary definition. So valuable analytic, an adjective noun pair, an analytic model of any type, regression, classification, ensemble, machine learning, neural network, that has caused the organization that paid for its development to change its decision-making in a way that has added business value to that organization. So there's a couple of key things in that definition. The first is, has caused it to change its decision-making in a way, right? So you have to actually do something different because of the analytic. And secondly, it's all past tense.
Yep.
Right? I'm not interested in projections, right? So I was being interviewed for an article the other day, and someone said, well, I'm my normal cynical self. And she asked me, well, how do I explain successful AIs? I said, well, give me an example. And she said, well, there's this AI algorithm that predicts tumors, that you have a tumor quicker than radiologists do. And I'm like, okay, I challenge your definition of a successful analytic. And she's like, how is that not a successful analytic? I said, because last time I checked, no one has been treated differently, lived longer, or spent less money on their medical treatment because of it. I'm not saying it couldn't be a valuable analytic, but it is not yet a valuable analytic.
I love that, because we've been to countless, you and I am sure have sat in the back of the room at countless conference presentations where they go, we are so excited about our area under the curve, or our R squared, or whatever. And next year, we're going to come back and we're going to talk about, ROI and value. We can't do that this year, but we can talk about all of our technical metrics about how wonderful it looks through, through the model.
Exactly. Yes. So in the context of what we were just saying, right, for instance, that, one of the things would be, for instance, you might build a very simple text analytic model that would predict how likely it was that this was, in fact, you had the condition we were talking about, right? Well, it might be a really crappy model, right? 55% accurate, right? Terrible model, useless model, right? But it's enough to cause the organization to change its behavior.
55% accurate could be a valuable.
Yeah, and therefore it could be valuable, right? Similarly, I could build one, the risk quintiles model is an example. Well, it's a great model. It hasn't changed the decision making, right? And of course, one of the problems in this valuable analytic definition that makes people pay attention is that it requires you to know what decisions you're trying to change. I was talking to a head of analytics. He's a new chief analytics officer. He just joined a company, and they had an analytics team. They'd gone off, talked to the business, said, what kind of analytics you really need? And they're like, we really need a particular kind of forecast that would be really helpful. Great. They went off, built this forecast. It's a great forecasting model, very accurate. Everyone's very excited about it. And as he said, and when he arrived, they were doing a roadshow about it. And he said, and that's a bad sign.
Yeah.
Because why you do a roadshow? Well, you do a roadshow to persuade people to use your analytic.
Oh gosh, yeah.
Yeah, and you've already lost, right? If you have to do a roadshow, right? That's you missed the point, right? Because they did try and talk to the business, and the business said that's what we need. But the trouble is, they probably don't need one forecast model. If they're like most companies, they need a dozen, because someone's got to forecast next year's, rough number for planning purposes. Someone's got to do next quarter for hiring purposes. Someone's got to do next month for repair and maintenance scheduling, and someone's got to do tomorrow for staffing.
Yeah.
Well, they're not all the same forecast, right? My trade-off between accuracy and timeliness, all those things are different. Right?
Yeah, so many things racing through my mind, James. I want to thank Angela for her comment. I support that. Go to market with what you have. Yeah, that's absolutely it. So again, my colleagues have put the link to the first article in the series, but the second article, because of course I've written it. It's well into it's nearly ready to go. I cite and link to your backwards, machine learning backwards, which I love that article. I think, when it first came out, I was, commenting about it. I just also want to very briefly circle back to this ICD-10 example that you gave earlier, because I've had countless conversations with clients about healthcare clients, about that same kind of thing. And if I tried to predict what ICD-10 applies to you or something like that, what are my chances? One chance in 10,000? That I'm right?
They're not good. Right?
Whereas if we're trying to predict whether or not I should go on a particular prescription med, if you're right 65% of the time, that might be a valuable analytic. That might be better. That might be better than the current model is doing. So back to you with this notion of valuable analytic. We have had some questions starting to come in, and I'm really going to start paying attention to questions, folks. So go ahead and let them loose at this point. But I have notes on some previous ones. You can choose manufacturing or underwriting.
Okay, I'll do that.
Do you have an example of a valuable analytic in either category or both?
Sure. Yeah. So start with manufacturing. So we did some work for a big manufacturing company. They're making a relatively small number of relatively large, expensive things. And they had classically gone off, hired some data scientists, done some work to try and predict quality problems in the finished product, right? And they had various kinds of predictions. And they were very excited that they found these ways to predict the potential things that once the thing was technically finished, it had to go be fixed, right, before it could be sold. Yep. And they were like, but so what? okay, we can't figure out how to use this. And so we said, okay, well, what decisions, could you make differently? If in theory, right? Well, the two
If
obvious ones
only,
were,
what's
yeah, right.
if only?
Well, but we do it backwards in this case, right?
Yeah.
What could you do differently because of the prediction, right? And one of them was, well, we could assign different people to tasks because a lot of the errors come from people just don't do the task very well.
Sure.
Okay, that would be the obvious one. But it turned out that because of the project managers in particular, and to a lesser extent, shift work and union rules and stuff, it was really hard to mess with the assignments. So we said, okay, so what do you have control over? Well, the quality team. And so we helped them define a decision that was, what is the highest value set of activities for this quality team on this line today? Right. And that was driven a lot by what tasks were coming up, whether there are particular kinds of tasks coming up, whether there were particular tasks that have been done in the past poorly that needed to be rewritten, redescribed, and the prediction of potential problems in future tasks was one of the things that drove that decision. So if they had a set of tasks that were in the plan coming up that were predicted to cause problems, it would select either a training class for those mechanics or a seminar on why you don't leave stuff behind on the finished product and stuff like that, right? And so it basically turned the quality team from, what do I feel like doing today, to given the schedule and the predicted quality problems, what could I do that might preempt those quality problems? Right. So that then made the analytic into a valuable one, right? Because now it's changing the quality team's behavior to intercept it. Now, I don't have the final data for that one because I never got the final ROI, but that was an example of from an interesting, wow, we can predict quality problems to here's what we can do because we can predict that.
No, I have a similar example, James, that I have to disguise because I have to, somewhat gently critique the model that they had in place. Because I'm sure you've encountered this, is that they've already tried to do this and maybe not successfully. Right. I'm sure you've had clients where that's the case, where you're coming in to save a project that was already attempted, and that was the case here. So they were trying to do repairs, and I'm hesitant to say the nature of the repairs.
That's fine.
It might reveal fine. But they were doing some repairs, and what they basically said was they were trying to figure out whether or not the repair resulted in a warranty claim against the repair, which of course is bad, right? So they have a little bit of money coming in, then they have this big chunk of money going out, and that's to be avoided. So I'm sure you're going to find this humorous. I certainly did at the time. I was just trying not to laugh in the meeting because it was a slightly embarrassing. Because what they were trying to say is that when we have inexperienced repair folks doing the repair, it's more likely to result in this problem. Well, the problem with that is what action is implied by that?
Right.
What's the if only? You already know, right? You already know that a rookie is somewhat more likely to make mistakes. So I think what you should really be doing, I told them, is figure out which projects rookies do successfully.
Yes.
And keep them off the projects that rookies make errors.
Exactly.
Don't tell me that rookies make mistakes. That is not interesting, and it's not actionable. It's not operationalizable.
Right. And it certainly wasn't worth spending any money on predicting, right? Right. And then underwriting, the other underwriting, we do a lot of underwriting work. And one of the ones in underwriting is there's a lot of talk in like life underwriting for predictive underwriting, right? And the problem with predictive underwriting is there's all these rules and history, and the underwriting manual is an analytic. Because why does it say, ask Keith these questions because he's this old and weighs this much and has this hobby? Well, that's an analytic that's based on the actuaries doing a ton of analytical work to come up with a manual, right? So the manual is an analytic. It's just a very oddball one, right? But and so when we were looking at it, we were like, well, what's the key problem here? Well, we have to ask too many questions of customers, right, before we could underwrite them, and they hate all these questions, right? So, okay, so well, what would stop you asking questions? And they're like, well, for instance, we have all this asthma questions we could ask. And if we had access to your medications, we might be able to essentially say, well, given your medications, you clearly do or clearly do not have bad asthma. Well, okay, so we've got a medication thing. So we could build a predictive model that would predict how likely it was that you had really bad asthma from your medications. And it might come back and say, I've got no idea because there's no medication history. Or it might come back and say, I've got a medication history. You clearly have terrible asthma. Or it might come back and say, you've got right? Well, now you can add that as a decision in the model, right? How likely is, right? And then the rules now say, well, if the model comes back and says it's really likely, we don't need any of the other data. That's enough.
Yep.
Or it comes back and says, well, the model says you clearly do not have asthma. We won't ask you any of the asthma questions. Right? And then if it's in the middle, we go ahead and ask you the asthma questions anyway, right? So what it's doing is, and one of the things I think is really important in this example is that the most common use case we see is that some transactions can be handled automatically. And I often find people with analytic work, they're trying to find an analytic that will help them not do something on every transaction. And I'm like, I think you're wasting your time. The odds that you have got one of those still lurking in your process are very, very small. It's much more likely that there's a subset of your transactions which you could not do something or do something differently. And the analytic will help you identify which subset that's true of, right? And so you have to be thinking about each decision as a separate thing. You can't just think of them as a set, right? Because the analytic is going to be making a different score, a different prediction for every transaction, every life in this case. And you have to decide how you're going to decide based on that prediction, right?
We've gotten to the stage where we can kind of look back on our conversation and see that it really if folks are thinking about it through this lens, it really all falls into place because you basically have these ingredients into the decision. You've got your structured data, okay? You have unstructured data that often needs human attention, and you've got the predictive score, right? And then you also have actions or even somewhat subjective opinions of employees, like the appearance of the patient, right? And what you really are helping your clients do is combine all those different pieces. So let's revisit the disability claim, the mobility, or the various different things. How would you coach a client to get all those pieces to work together? This is a really powerful note to end on. How would you, what kind of systems would you be coaching them to have in place that would possibly be calling out to an external workforce to get that clarification about what's in that paragraph and then circle back? How would that all work?
Right. So we have a sort of standard pat phrase we always use. We do everything decisions first, right? So we always begin with the decision in mind. So we would say, before you do anything else, figure out how you're going to decide whether you're going to pay a claim or not. Because the process exists so you can pay the claim. It has no other purpose, right? You're not going to do this process other than to decide if you're going to pay the claim or not, right? So designing the process first gets you nowhere, right? So you have to understand your decision making, right? So that's the first mistake people make. They have this whole process that they're going to go through, and I'm like, well, why? What decision are you trying to make at the end of this? So now you have a decision, right? So you say, okay, in order to make that decision, I need to know certain other things, right? And I start to say, well, can I define a set of rules for them? I might automate those in a business rules management system. Often that's the first step. I get some automation and consistency and control of that. So I get a little bit of straight through processing, a little bit less manual intervention, and I start to make some money, to your point, right? I start to get an ROI, right? Then we would say, okay, then we do this if only thing. If only I knew this, if only I knew that. And then that starts to identify ways to look either at structured data in a complicated way, like historical analysis or forecasting or prediction, or unstructured data, right? To text or images or whatever. And then I would divide those up into 3 buckets and say, for each of those decisions, does the data science team think they can realistically make a prediction from your data, given the training data sets they've got, that's accurate enough for you to decide differently? And they're different, every one. There's no such thing as the right accuracy, right? It all depends on the context. The second thing would be, is it something that you really feel like you only want an employee to do, or that realistically only someone who's deeply steeped in your company's policy manuals and everything else can possibly do, right? They've got to talk to a customer or something else, right? Or is it something you just need a smart human to do, right? And now I've got this single decision model with all these different kinds of decisions on, right? 30, 40, 50 sub-decisions probably. And some of them are rules-based, very structured. I know how to execute them. Some of them are analytical. I'm going to call them a score. There's a score or a classification or something. And then the others are human decisions, right? So now I've got this decision model, and I can automate big chunks of it. And so then what I would do is take a business process platform, a workflow or case management platform, and say, okay, transactions come in. I'm going to take the data I get right at the beginning and see if I can decide. Because if I can decide, I'm done. If I already know enough to say no, I don't need a process, right? I can just say no, right? But if I don't, then I identify which bits of the decision I can't yet make. And then I go try and make them, right? I route it to an employee so they can do it. I pass the data off to someone like Cloud Factory so they can come back and say, hey, we looked at it. This is true. That's not true. I call an analytic model to score things, whatever I do. And then I try again. I take that new data set, now enhanced with these additional qualifications, and run it through the decision engine again, because I never want to override the decision engine. I want to feed my overrides into it, right?
Yeah.
So that at the end of this process, I get this is the decision we made, and I know exactly why. How I use different people's judgment, how I use different analytics, how I applied our policy rules. I have an answer. That creates a data set that goes back to the data science team so they can start to say, you know what, we noticed that we keep doing these 6 things, but whenever we do those 6 things, we always get the same answer. So why are we doing the 6 things? Right? They start to make bigger, more sort of like lumpy kinds of suggestions about ripping big chunks of the process out.
That clarifying the input, that improving the quality of the data, not overriding the outcome, is so powerful to me, and really is the fundamental one. So again, in terms of an external workforce, what you basically have is you have these definite yeses and these definite nos, and then you have, again, we'll credit you the phrase, you have the squishy middle. And so let's say there's 20% in the squishy middle. 5% or a fourth of the squishy middle, whatever you want to call it, might have to go to a radiologist or some kind of expert or something like that. But the lion's share of the squishy middle could be put in a queue where some clarification has to be made. Is there any evidence in this paragraph of, doctor's notes? It could even be potentially handwritten. You'd have people going crazy trying to deal with the handwriting deal with that next year. Don't deal with that now, right?
We did a project in Hong Kong with Chinese handwritten medical bills. So really, just don't go there.
or put it on your to-do list for 2026, but don't prevent it from you getting now, right? So that gets routed out to someone, and they have a task that, again, is not a crowdsourcing task, but it doesn't require an MD either. Is there evidence of a mobility problem here? Is it justifiable that this person has a claim against that? We're in our closing minutes, so I want to give someone the honor of the final question, if anybody can type quickly enough. But again, scroll through the comments, everybody, because there's some really valuable stuff in there. Open up that window if you haven't done so already, and start by following Cloud Factory, and then go ahead and follow James and myself and the other folks that have been involved in the series, because stuff about all of this will be in there. Make note of the article. The second article will be coming out next week, possibly even with a quote grabbed from our conversation today. But I found it extremely valuable. And, the articles will really kind of go in nicely. And look for that link where I mention, how did you phrase it, James, about the backwards? It was because I put it.
Doing machine learning backwards or something.
Doing machine learning backwards. Yep.
Right. So if we don't have a last question, I mean, I would say that there's 3 things we've learned from doing these projects, right? That if that you can do right tomorrow and do better, right? The first is this: begin with the decision in mind, right? Don't do an analytic project or indeed a Cloud Factory project if you don't know what decision it is you're trying to get better at. Because in the end, that's what data is for. When people say, I want to be data driven, I want to use analytics, they mean decision making. Well, you can't just improve decision making in general. You have to improve decision making in specifics. So know which decision you're trying to get better at and what better looks like, so that you know what you're trying to do, right? The second thing is, it's never going to be just a machine learning or just an AI problem. Yep. It's always going to involve people. It's going to involve machine learning. It's going to involve data mining. It might involve descriptive analytics, business rules, all sorts of other things. So don't let it be driven by, I've got to use technology X. Right? Technology-led programs never work, right? Yep. And then lastly, you've got to focus on continuous improvement. The biggest challenge with a lot of data science teams is they build the model and they ride off into the sunset.
Yeah.
Go work on another model, right?
Go to market this year. Do something this year.
Yeah, right. Do something this year, and do something that has a plan that make sure that your version 1 product includes a plan to improve it. Don't ever let the continuous improvement be phase 2, because phase 2 never happens in a big company, right? So phase 1 has to include creating the environment that will let us see how we can improve it. Right. So one of our biggest bitches with big clients, they want to say, well, can't we leave all that sort of business rule maintenance and feedback loop and dashboardy stuff till phase 2? And we're like, no, because you won't do phase 2. We know you.
Yeah.
You'll just do phase 1 and then you'll get distracted by something else. So no, it's going in phase 1. It's got to be part of the initial deployment.
If they use that approach, there'll be no phase 2. But
Exactly.
if they develop a valuable analytic in phase 1,
right,
then there probably will be
exactly.
Exactly. I think I know what some of the quotes in the article are going to be. I definitely want to add some in there about the if only. That the learning isn't about everything. It's about the if only and combining that with existing processes to drive decisions. We've already spent an hour. It's hard to believe. I had a fantastic time. I hope the audience did as well. I want to thank you very much, James. One final note for everybody, one little bit of housekeeping. Sometimes the recordings are a little bit hard to find, but if you go to Cloud Factory's events page, I'm sure you'll be able to find this if you want to watch parts of it again, or if you caught us halfway through. And then finally, if you want to keep the conversation going, what I would suggest is that since the recordings are sometimes a little tricky to find, but the articles are not hard to find, if you didn't get a chance to ask your question today, or you didn't think of your question today, ask the question below the article that comes out next week. I'll be tagging James. I'm sure he'll stop in from time to time to answer some of those questions, and that'll be a great way to keep the conversation going.
And I'm going to make a shameless plug. If you're a book reader, shameless plug for this book. Digital Decisions.
New edition too. New edition, right?
New edition, yeah. It's nice and thin, so it's a nice, easy book. If you're interested in this kind of stuff, it's my book, so it's fabulous. But it's just, I thought I'd shamelessly do it, but I did wait till the end to shamelessly plug it in my defense. So
well, it is a fantastic book. And again, the articles, they can check out the article first, and if they're as impressed with the article as I think they will be, then I think very naturally they're going to end up checking out the book as well. Adrian just complimented us on doing effective summary at the end. I really did enjoy it, everybody. I hope that you'll return next month. Again, do a last minute scroll through the comments if you haven't done it and grabbed all those links. And in a month's time, we will do this again with Ian Barkin. Thanks again, James.
All right.
Take care, everybody.
Thanks, Keith.
Cheers.